Hi, I'm going to be talking about Unit 1, Objective 3. So, I'll be talking about isotopes, nuclear decay, radioactivity, and a little bit about how PET scans work to find cancer. So the first thing to know is isotopes, which are the same element with a different number of neutrons. And the reason this is important is because neutrons not only give mass to the element, but they provide the strong force. And the strong force is what holds the protons together because they're trying to go apart from each other because of the electrostatic force, because they're both positively charged. So they don't want to be together, but the strong force puts them together. However, the strong force is limited by distance, and this is what leads to radioactivity and nuclear decay. So when you have your element, and say it has 82 protons. So it's all good, it's being held together, the strong force can still reach it, and it is stable. However, once you add an 83rd proton, the element just becomes too big for the radius just becomes too big for the strong force to hold it together. So that electrostatic force of the protons pushing against each other is just too great for the strong force. So the element becomes unstable because the nucleus just can't hold together anymore. So what happens is the nucleus decays, and that's in a form of radioactivity. So there's alpha radiation, beta radiation, which I'll go into, and gamma radiation, which is like high intensity energy being released from the cell. So beta radiation is when you have your nucleus with some amount, 83 or more protons in it, and it's unstable, and so one of the neutrons in there is going to decompose into a proton and an electron, and the proton's going to stay in there and the electron's going to go out into space. But the proton it's still unstable because now it just has an extra proton and one less neutron, so it's still big, but it has less strong force. So it's going to release what's called an alpha particle, which is 2 neutrons and 2 protons. So four subatomic particles are going to go out, and that's going to make the nucleus obviously smaller, and it will be small enough so that it's stable, or if it's still too big, it'll just repeat that process until it becomes lead, which is the last stable element with 82 protons. So scientists use this obviously to create like energy and stuff. So the way they do that, one method of how they do this is they take a positively charged hydrogen atom, which is basically just a proton, and they fling it into an element. So let's say you have oxygen, and the proton is going to go into the element, and it's going to kick out one of the neutrons. So your element has now changed. In the process of elements changing from one to another, which is what happens in nuclear decay in this case, it's called transmutation. So you now have this element that it's no longer oxygen now it's fluorine. But because it lost that neutron, it's an isotope of fluorine, but it doesn't have enough. It has less neutrons than protons, so it's going to be unstable. So that is a way that they create radioactive particles, because once they have this unstable nucleus, it'll decay and produce radiation. So that kind of leads into how PET scans work. So they replace a oxygen atom in a glucose molecule with a radioactive fluorine, and glucose is used by the cells as energy. So tumor cells and cancer cells use more energy because they're growing faster than most other cells, so they will use more glucose. So the glucose is injected into the body and it goes all throughout, and the cancer cells will start using more of it, and so the radioactive glucose will start to be concentrated in certain places where there's cancer, and it will start to decay and release off radiation. So the PET machine can pick up where this radiation is coming from, and create an image of like where the cancer is. So yeah, that's just about it. That's objective 3 for Unit 1. Thanks for watching.